So hello friends, myself Debasish Chakraborty. Today we are starting the video tutorial on ASA Firewall, Cisco ASA Firewall. In my introductory video, I have already discussed, or rather I have already given you a list on the different topics that I'll be covering on ASA Firewall. So today is the first training video that I'll be starting today, and this particular video will be entirely a theoretical video because we need to know certain basics about firewall. Once again, I assume that my audience friends, you are coming from different levels, right? You may be a fresher, or you may be a mid-level executive, or you may be a highly experienced professional, but nevertheless we cannot ignore the fact that whenever we need to know something, particularly in case of information technology, which is very vast and which has a lot of variations, we need to once again recapitulate the theoretical and the most fundamental areas, right? So for that reason, I have prepared a PPT presentation which I will read out today, and I will explain today, of course, so that when from the next day onwards, when I'll be going into the practical demonstrations, we won't be facing any kind of conceptual confusions, right? So let us start with the theoretical video. So what is actually ASA? ASA, or in its full form, Adaptive Security Appliance, is basically a firewall solution from Cisco, and as a result, whatever we must be learning regarding ASA is all about firewall. So even if we are presently having a huge variety of firewall solutions, some of those solutions are direct hardware devices, while some of them are certain softwares, or rather operating systems, which can be put into certain box and can be executed, while some other kind of firewalls, they are purely application level softwares which are embedded into the operating system or into some other softwares. So whatever be the case, every firewall has certain salient features. So in this particular video, we'll be just highlighting those salient features of the firewalls. Definitely each and every product from each and every vendor has certain specialties which are not present into the products of other vendors. So that is basically the USP of that particular device from that particular vendor. But there are certain underlying features which are common to all varieties of firewalls coming from all the different vendors. So we'll be just highlighting and we'll be just recapitulating those areas. So what is a firewall, right? So it is basically a system. It is basically a system that is used to filter traffic entering to or exiting from a network, and it can be a hardware device or a software program, right? So if we are following this very simple diagram, we see that this is actually the firewall, and it is rather seated at the gateway point or at the perimeter of a particular network, and at some other point it is connected to the internet, right? So it is basically sitting midway between the internet and a particular network, right? And from the internet we see that certain types of traffics are coming some of them are desired, while some of them are undesired, right? So how we decide this desired and undesired, that is actually a matter of specification, because it depends upon what type of situations we are facing when we are actually meeting these traffic, right? Whenever we see that certain traffics are useless, or certain traffics are quite dangerous, and our networks and our different hosts connected to the networks, they are becoming vulnerable, they are having certain threats from those traffics. So definitely we consider that particular traffic as undesired, while the useful traffic and the harmless traffic, they are the desired traffics. And we actually specify this whether we desire a traffic or not. That specification is actually done on the basis of several factors. For example, we can specify the source address of the traffic, or the destination address of the traffic, or the protocol that the particular traffic is carrying, and several other issues, or maybe a certain website, a website address from where that particular traffic is coming, certain other features like whether that particular traffic contains some kind of ActiveX controls, and certain other features. So there are several ways to classify and to specify those traffics, which we are actually considering as desired or undesired, right? Now that type of specification is actually written in in the form of access lists, or access control lists, or ACL in short. So we'll be touching the access control lists obviously whenever we'll be formulating the policies for the firewall. In fact, every firewall, whenever we are formulating certain policies for that firewall, it is its foundation, the foundations for those policies are nothing but access control lists, right? Even if you are tuning your Windows firewall, or if you are tuning your antivirus firewall, so they are all done on the basis of certain access control lists, right? So definitely we'll be touching access control list, although I am sure that whoever is doing this curriculum, that person is having some basic idea about access control list, but still I'll be just giving you certain hints on access control list. Anyway, so the main purpose of this firewall is to filter out this undesired traffic. You see, the undesired traffic cannot come on this side, whereas the desired traffic is coming on this side, right? So this is the main purpose of firewall. So firewall is basically that system which filters the traffic that is entering to or exiting, even when the traffic will be coming out, right? There may be certain traffic which will be coming out from this network. In that case also, if the need arises, then the exiting traffic, that can be also filtered. So that is to be done by the firewall also. Not only it is filtering the incoming traffic, it is also capable of filtering the outgoing traffic, right? And it can be a hardware device or a software program. This we already know, because if you are considering the hardware device, in certain cases, for example, Cisco ASA, this is basically a dedicated box which entirely looks like any router or switch with certain ports and console ports and certain other data ports like the fast Ethernet ports and gigabit Ethernet ports and so on. So these are pure hardware firewalls. Yet if you are considering Windows firewall or the firewall which are present in antivirus. So they are the pure software firewalls, right? And yet there are certain other firewall solutions which can be put into a box. For example, if you are considering Checkpoint. So Checkpoint has an operating system which you can install on your PC, right? On your PC, and then if you are equipping your PC with more than one network interface or NIC, because if you are considering a single PC, it has a single NIC, but if you are putting some 2 or 3 NICs on the PC, then very well you can use that PC as a Checkpoint firewall, right? Definitely Checkpoint also comes as a boxed device, but Checkpoint has this facility to use its operating system into a PC which has which is equipped with more than one NICs, so that you can connect it to several networks and you can provide them with security. And in that case, that particular PC works as the Checkpoint firewall. And this is not only for Checkpoint. If you are considering the different firewall solutions, the modern firewall solutions like Palo Alto, so they also have this feature, right? And another thing I would like to point out at this particular area, that when we are concentrating on ASA, it is basically a network firewall, right? It is not a firewall that is designed to protect a particular host. Obviously, you can dedicate it. You can dedicate it for providing the protection for a particular host or a particular server. That's your choice, right? But in general case, we use these types of firewalls like this Cisco ASA, FortiGate, Palo Alto, all these types of firewalls. We are using them to provide the perimeter security. That is, they will be protecting the entire network, right? Not only a particular server or a particular host, they will be protecting the entire network. Even they, in many cases, they are providing protection for different networks depending upon how many interfaces they have and to how many networks they can connect, right? So now let us proceed to the next page. Now here we get a logical view of a firewall, the logical sectional view of a firewall. So if you consider this as a firewall, it has 3 distinct regions. One is outside, another one inside, another one is DMZ, or in full form it is demilitarized zone, right? So the outside, the section which we consider as outside, that is connected to the internet. The section which we consider as inside, that is connected to the internal network to whom the security is to be provided, the highest level security is to be provided. And the section that we consider as DMZ, there we can place certain devices which definitely belong to the company, but they are not to be put into this inside zone, right? Why not to be put into this inside zone? Because in this DMZ, we normally put certain servers which needs to be accessed from outside, right? For example, your company has a server, which particular server hosts a website which is not connected to secure data, right? That particular server is not connected to secure data. It is just for hosting a website, which is, that website will primarily provide the viewers the informations regarding your company. And at the same time, there may be some kind of a small form, right? Some HTML form where the interested customers, they can put their details, right? So if we are putting that particular server into the inside zone, then it will not be possible for any fresher or any interested customer who is definitely not belonging to your company to access that particular server, because the inside zone will be getting maximum security and only the authorized persons are allowed to communicate with the inside zone, right? Now, the authorized person should be someone who belongs to the company, definitely not someone who is coming from outside. So we need to put certain company resources in certain sections which are not so protected, right? Rather, their protection is rather a 50% approximation of the protection that we are providing to the inside zone. Now, that type of zone is called the DMZ or demilitarized zone, where there will be security or there may not be security, right? It is not a mandate to provide a security at DMZ. It is enough if we are providing there with a medium level security, because we need not be putting too much of restriction in the DMZ, as people from outside will be contacting the servers which we are putting in the DMZ, right? That's why this is called demilitarized zone. This is not a pure militarized area. It's not a purely protected area. And the hosts or the servers which we are provisioning here, they are technically called Bastion Hosts, right? So the Bastion Hosts are actually certain devices which are not so which do not need that much of security, and even if they are compromised, that will not do a devastation for the company itself. So they may get compromised. Obviously, we should be doing something to protect them from those kinds of compromise attacks. But even if they are getting compromised, it will not be a devastation for the company itself. So we put those kinds of servers and hosts in the DMZ area, and we call them as Bastion Hosts. Sometimes we also do a very intelligent trick, because if we suspect that from somewhere outside from the internet we are facing some kind of malicious traffic, and we suspect that some kind of a hacking activity is going on, it is certain kind of hacking activity is targeted towards our company. In that case, we can even place certain servers which will be just providing a identity that they are genuine servers containing some genuine valuable websites. Those websites contain valuable data, but actually they are the honeypots, right? So whenever that hacker is trying to access that particular honeypot inside the DMZ area, in that way it will not be any harm to the company, obviously, because that particular server is not having the real valuable data for the company, but it is having some fake valuable data. And when that particular hacker or unauthorized access is done on that particular server, and later on when we check its log, we can now very easily understand from where this attack has been done, right? So for this reason, those kinds of devices who actually imitate the genuine devices, genuine assets of the company, but actually they are not. They are simply imitating. They are simply just giving them a false identity as very valuable devices of the company. They are actually called the honeypots. They are maintained in the DMZ just to track the details about the unauthorized hacking accesses, right? And the outside, this is basically connected to the internet. It has it has no security at all, right? Because if you are putting security here also, then the traffic from internet will not be able to come inside the firewall, right? So they must come inside the firewall, and after coming inside the firewall, they'll be getting filtered, right? So if they are directed towards DMZ, that filtering will not be that much stringent, not be that much strict. But if they are targeted towards the inside network, that filtering will be very, very vigorous filtering, and only the authorized persons are only allowed to enter the inside zone, right? So we have these three zones: outside, inside, and DMZ. Outside has no security, inside has maximum security with very limited access, and DMZ has medium level security. In some cases, even you will find that DMZ is having no security at all, definitely, which is not a very wise situation. But if you are employing the trick of maintaining the honeypots at the DMZ, so in that case it is better not to provide any kind of security in the DMZ. Otherwise the unauthorized those accesses will not be successful and will not be able to track the different sources of those unauthorized attacks, right? Now you must be careful about this point, that these three zones, they do not represent single interfaces, right? They can even represent multiple interfaces. That means outside zone can have multiple interfaces, inside zone can have multiple interfaces, DMZ can also have multiple interfaces, right? So and not only interface, you can also have sub interfaces in these different zones, right? So these are zones, these are not interfaces. Maybe they comprise of single interfaces, or they may be comprising of multiple interface or multiple sub interface. That depends upon your how you are designing your network, right? So these are the three sections. Now let us move into the next slide. Now here this is certain small definitions, short definitions. So inside network is internal network of an organization. This is highly trusted with maximum protection and no access from any other side, right? No access from any other side. Very interesting point. I'm coming to this very soon. Now outside network, this outside network or internet, totally untrusted and no security zone. And DMZ or demilitarized zone, where the internal network, this is definitely an internal network of an organization, because don't consider this to be an outside network, right? If you are considering the company network perimeter, the organization perimeter will be something like this, right? It will be something like this, where I am drawing the mouse. So the organization perimeter will be something like this. Organization perimeter ends here, not here, not here, right? The firewall itself is included inside the organization, and the perimeter ends here, where the firewall actually touches the outside zone, right? So definitely the DMZ is an internal network of an organization which can be accessed from the internet, right? I just discussed that particular point a little while ago. Now the data flow pattern. Now here we see the data flow. Anything can go obviously from the inside to outside. Anything can go obviously from inside to DMZ, but nothing can come from DMZ or outside into the inside. Whereas the DMZ and the outside, they can exchange their data. That means if some traffic comes here, it is not allowed to, it will never reach this inside zone, right? But it can reach the DMZ. Whereas if a DMZ traffic if a traffic is coming from the DMZ, it can very easily go to the outside, but it can never go to the inside. Whereas if a traffic is coming from inside, it can go everywhere, right? It will go to the outside, it will go to the DMZ. Now the question will be coming up like this, that if any traffic is not allowed to enter into the inside zone from outside or from DMZ, then how come the inside users, the users who are sitting in the inside zone, they get traffic, they can see the internet, or they can see the company website? Yes, definitely that needs to be done. But what I have discussed here is basically the default nature of any firewall. Whenever a firewall is not configured, whenever it is left to its default, in that case the firewall will behave like this. Anything is allowed from inside to go to anywhere, whereas nothing is allowed from anywhere to go into the inside. So this is the default property of a firewall. Now we need to break it. Now why we should be breaking it? Because the users who are sitting in the inside zone, they need to communicate outside, or they need to communicate in the DMZ. So to facilitate that, we provide some specific level of permissions, or specific sets of permissions which we configure in the form of access control lists, that such and such traffic is allowed to enter into the inside, and no other traffic which is not matching this criteria will be allowed into the inside zone, right? So in that way, by specifying some very stringent rule sets, we allow some specific class of traffic from the outside or from the DMZ into the inside, right? In that way, we meet two purposes. First of all, we can provide security for the inside users from the rest of the world, and at the same time, the very important traffic for the inside users, they can also come from the outside zone and DMZ into the inside zone, right? So this is the data flow pattern. This is a default data flow pattern, right? Don't consider it as a firewall will be always behaving like this. No, that's not. So that we can override this default behavior, we need to write some access lists that we'll see when we'll be from the next day, when I'll be sitting with you with the practical demonstrations. There you will see that I'll be putting their access control lists. Now types of firewall, right? So firewall can be categorized under certain heads, although I have given their bullets, but let me tell you at this point that this is a particular head where we can classify firewall on the basis of hardware or software. These two are another level of classification where firewall can be packet filtering or application filtering firewall. Another classification can be stateful and stateless. Another can be router mode and bridge mode, right? So although I have written here these 8 points under the same bullets, just consider them as 4 blocks, right? So these two are one category, these two are the second category, these two are the second category, the third category, and these two are the fourth category. So on these 4 categories we can classify firewalls, right? So first of all, we can have hardware and software firewall. So hardware firewall is a dedicated hardware for firewall purpose and can protect a particular device or an entire network. Little while ago, I discussed that you can make your ASA a dedicated firewall for a specific server, or you can provide a perimeter security by using your ASA firewall. So this is the beauty of hardware firewall, where they can serve these two purposes. Whereas a software firewall is a software program for firewall purpose and can protect only a particular device. So if you are considering your Windows firewall or your Linux IP table or your antivirus firewall, in all these cases they can provide security to that particular device on which they are installed, not for all other devices. Packet filtering firewall and application filtering firewall. So packet filtering firewall is which can filter only IP packets and not definitely very effective. An application filtering firewall is which can filter on the basis of specific applications, can do content filtering, URL filtering, etc. So obviously by using your very common sense you can understand that this is a much sophisticated firewall, and nowadays all firewalls, all sophisticated firewalls are application filtering firewall. Obviously they can do packet filtering, but whenever they are doing a packet filtering, it is basically filtering on the basis of IP address, maybe source IP address or destination IP address and so on, right? Now in that way you cannot control today's harmful traffic, because nowadays it's very easy to hide your IP address, right? So the person who wants to do some harm to your organization network, whenever he sees that the IP address he was using previously is blocked by a packet filtering firewall, he can very easily change his IP address into some other. So that can be easily done, right? So packet filtering firewall is not very effective nowadays, whereas the application filtering firewall, they are actually the most effective firewall. For example, if you want to block YouTube, right, in that way you cannot simply block by blocking its IP address. You have to block the URL. You have to block a particular URL which contains the string youtube.com, right? So in that case you have to go for an application filtering firewall where it can analyze the URL, and if it sees that that particular URL contains youtube.com or say facebook.com or say gmail.com, then it can, or some xyz.com, then definitely if you are already writing codes to your firewall that you should be blocking these kinds of traffic where the URL contains such and such strings, that can be done, right? So definitely application filtering firewall is a much sophisticated firewall, and today all the firewalls that we use, they are all application filtering firewall. Stateful firewall and stateless firewall. So stateful firewall is which can keep track of connections going out from inside, so that reply connections from outside is not filtered by the firewall, whereas stateless firewall is firewall which cannot keep track of connections from inside. Now let me visit the previous slide once again. No, not this one, this one. What I have told a little while ago, that is nothing is allowed to enter into the inside, right? By default nothing is allowed to enter into the inside unless and until we are making some provisions, right? Now there may be certain kind of traffic which has a return counterpart also, right? Say for example if it is a TCP traffic. Now in case of TCP, whenever it is a question of TCP connection, a TCP connection has something which is called three-way handshake, right? So where at first the sender will initiate the connection, and it will be sending a message to the receiver. The receiver, that particular message is actually called synchronize, or SYN in short. The receiver will be sending back another message which is called synchronize acknowledged, and finally the sender will be sending its final acknowledgement. So that's why it is a three-step process, right? It's a three-way handshake whenever a TCP connection is established. Now you can very easily understand that whenever I being the sender, if I am sending a synchronize or SYN. If I am sending a SYN packet, obviously I'll be expecting a synchronize acknowledge or SYN ACK packet from the other side. Right, the other side should be spontaneously replying me back with a synchronize acknowledge. Unless and until that other side is unable to accept my connection, or it is also having some restriction that it should not be accepting my connection, right? So if we are not considering situations like those, the other side is bound to reply me back with a synchronize acknowledge for the second level of the three-way handshake. Now, my SYN message will be going from the inside to the outside where my target is, and my target will be sending me back with a synchronize acknowledge or SYN ACK, which will be coming from outside to inside. Now here, if the firewall is a stateless firewall, it will drop that synchronize acknowledge message. Why? Because that message is trying to enter from a no security zone to a very high security zone, right? So it will not allow it to enter. So that means I will never be able to establish a TCP connection with something which resides outside, right? And if I am unable to do that, definitely I will not be able to continue with my application layer protocols, because application layer protocols will need TCP to build the platform at first, and then only they can work. So in that case, the stateless firewall will fail. Now it will be a very, very nice situation if we are having a firewall which can understand, which can distinguish which traffic is actually a response traffic from somebody's action from inside, and which traffic is not a response traffic. So if any non-response traffic comes here from the outside zone and trying to enter the inside zone, then it will be dropped because it is not having that permission. Whereas if it is a response traffic like that synchronize acknowledge message, it will, if this is a stateful firewall, it will keep track that it will be having a table which is called a connection table or state table. Now inside that state table, it keeps track that some particular host from the inside network has sent a SYN message to someone who is residing outside, and definitely a synchronized acknowledge message will be coming very soon, and I need to make a way for that because it is a reply message or response message for somebody's query from inside. So a stateful firewall actually distinguishes, it can distinguish between a response or reply message and which is coming from the outside, and a ordinary message which is also coming to enter from the outside, right? So if it is an ordinary message, if it is a just self-generated message which is coming from outside, it will be dropped immediately. Whereas if it is a reply message, it will be given that passage, right? So this is the difference between stateful and stateless firewall. Here at this particular point, I would like to draw an analogy here. If you are getting confused with this particular area, with this particular concept, that why it should not be flowing from outside to inside by default, whereas it is flowing from inside to outside by default, just consider it as water levels. Can we have the level of water rise from bottom to top? Definitely not, unless and until we are using a pump, right? But at the same time, we can very easily see that water flows from top to bottom. We don't need any pump in that situation. So here also the same thing happens. When it is coming from inside zone, it is a high security zone. Here the level is actually considered in terms of security. So it's coming from a high security zone, definitely it will fall towards a low security zone, the traffic. Whereas when it is coming from a low security zone, it cannot rise. It cannot rise to enter the high security zone unless and until we are using a pump. and that pump is nothing but that access list, right, which we configure at the firewall so that certain traffic are allowed from this low security zone to rise into the high security zone, right? Okay. Now coming to router mode firewall and bridge mode firewall. Now router mode firewall is that which is placed between two or more networks and can filter traffic when it moves between the two networks or the networks. And bridge mode firewall is firewall that is placed inside a network to filter traffic moving inside that particular network. Now bridge mode firewall is not a very common situation, because if you see the definition, you can easily understand that this is actually used to provide host level or device level security, isn't it? Individual device level security. This is not for providing a network level security. Router mode firewall, as it is actually placed at the network perimeter, so it actually protects the entire network, and it works as the default gateway or the router for that particular network, right? And whenever we think about firewall devices, by default that comes into our mind that this particular firewall device is actually working as a router mode firewall because it is situated at the network perimeter, and it is now working as the default gateway for this network, and it is also the routing device for the different hosts which are connected to the network. In terms of providing gateway, in terms of providing security, in terms of providing the route, it is doing everything for all the hosts which belong to that particular network. That's why it is a router mode firewall. It is a firewall, at the same time it is working as a router also. Whereas when we are very concerned about certain threats which are actually happening inside a particular network, say for example I am sitting into my office network and I suspect that some kind of this unauthorized access is happening, and that is coming from my colleagues, right? So in that case I can use a firewall into a bridge mode. Now here the firewall will be placed where the switch is present, the switch or the hub is present, and in that case it will be filtering the traffic which is running between the hosts which are connected to that particular firewall. And in doing that, it actually provides a security for the different devices. So it is in essence providing a device level security individually, right? It is not providing a network level security. It is providing a device level security. It is not providing a security for the network, because if we are placing a firewall in the as a bridge mode firewall in the place of a switch or hub, what will happen if we do not have a firewall at the perimeter? So definitely malicious traffic from outside will enter into the network. So the network itself is not protected, rather the hosts are protected, right? Now this employing a firewall in this way has its limitations. Number one point is firewall will not be having too much of ports. Its ports density is less than that of a switch and hub. For that reason, as we are now when we are employing the firewall as in a bridge mode, as we are interested for individual device level security, that means each and every device should be connected to the firewall, right? So that may not be possible because the port density of firewall is not like that of a switch or hub. So this is number one minus point. Number two minus point, it is not at all a wise decision to deploy a firewall in that particular position, because firewall is a costly device, right? It is costlier than a switch and a hub. And number three, if we are considering the issue of device level, individual device level security, it is better. It is better if you are using any software firewall. Nowadays we have very sophisticated antivirus or anti-malware softwares, so we can very easily install them, plus the different operating systems whether Windows or Linux. Nowadays they have quite sophisticated level of security by using their firewalls and those bit defenders. So in that way, just by doing a proper tuning and an efficient tuning of these softwares, of the software firewalls, we can very easily provide individual device level security. So definitely putting a firewall in the bridge mode is not a very wise decision. Nevertheless, if we are facing a situation like that, then definitely we'll have to do that. When I'll be doing the practical, I will show you how we are deploying our ASA firewall as a bridge mode firewall. Now, other features of firewall. So till now we have discussed that firewall is primarily a filtering device which filters the traffic which passes through it. Now, apart from that, it also has certain features that it can work as a default gateway of a particular LAN. Right now I have discussed it. If you are putting it in the router mode, then definitely it is a default gateway for that particular network. Can provide VPN service. We'll learn it. We'll learn how to configure the site-to-site VPN using the Cisco ASA firewalls. Can provide network address translation service. Obviously, if we are putting it in the perimeter in place of a router, then it can also do a NAT, that is hiding your network from the rest of the world and giving a totally new network identity for your network. In fact, on the outside, that is on the internet side, your network will be represented with its public address, right? So nobody will be able to know what is your actual IP address. It can provide proxy service. Proxy service, all of you know, where it can, if we are like want to visit a particular website, in that case the firewall will at first download the pages of that website into its cache, and then it will provide us. It will serve those pages to our computers. So that means it is actually giving a proxy. It is giving a proxy for that particular website. Can be used with failover mechanism to provide high availability, right? So what is high availability? High availability means your device, or rather your system, not device, your system, any kind of system, if it is available 24/7, then it is called a high available system, right? Now, how we can make rather facilitate that kind of a system? Obviously, we need redundancy of devices. If my present firewall fails, then immediately the next firewall should be taking up its charge, right? So there must be a redundancy of hardware device, no issues on that and no doubts on that also. At the same time, there must be a complete synchronization and understanding between these redundant devices, so that if the present working device fails, immediately within the flicker of an eye, the backup device should be starting to serve the different clients, right? So this is actually called high availability, where our system is available 24/7, and we will also learn in our video tutorials how to configure this failover mechanism in our by using our ASA firewalls. So this is all about the first class. I have told you when I started with this class that this will be a pure theoretical session, and this will be a very simple session also, because I will just highlight, I'll just point out, I'll just do a recapitulation on the different salient features that are present in every form of firewall. We cannot think of a firewall which is not having these features, isn't it? And later on, when we'll be going for the vendor specifics, like when we'll be doing ASA, or later on if we are going for Palo Alto or FortiGate, in that case we'll also come across certain new technologies which are specifically the USPs of those brands, right? So this is all about the first class. I hope I have helped you to clear your doubts, or rather to freshen up your memories regarding the issues of firewall. But still, if you are having any doubts, any confusions, please feel free to come up with those via my WhatsApp and email. And obviously, if you have some fresh inputs which I haven't pointed out here, you can also come up with that, because I have already mentioned this fact in all my videos, that the world of information technology is such a world where no one can boast that he is a supreme one, right? I have several students who are always ready with some new facts which I have completely missed out. So any new facts is always welcome from you people. So that's all for today. I thank you for your immense level of patience and cooperation to attend this class. I'm very happy to have you as my students and as my followers and as my friends also. I'm very eager to see you in the next class, when we'll be starting with our practical sessions. Bye for today. Thank you so much.